So now you're going to tie in probability to everything that you've just learned about sets. And so instead of having it be a set A, you would either see it as like it would be listed as a set, or it would be, oh, event A, things like that. And so just some basic things with probability, just because I don't know, honestly, I don't know if you've touched probability since like 7th or 8th grade. Okay, so just a brief refresher. Probability, the likelihood of something happening. Which I think you're pretty familiar with. But as far as mathematically, the denominator, it's like the total number of possible outcomes, that you could have from like, rolling a die, And then the top is the number of ways the event can happen. So, for example, you're going to roll a die, or should I call it a number cube? Either way, you know what I'm doing. Okay, so you're going to roll a die, and we're going to say event A is going to be rolling an even number. So if I wanted to list set A, well, what are the even numbers? 2, 4, 6. There you go. And then we're going to look at the probability of A. I'm going to do this in green. This is going to be listed with a P, so that P is meaning probability of event A happening. Well, there are 3 even numbers out of my 6 possibilities, so I got 1/2. We could also call it 50%, or I could put it as 0.5. You're going to see in all variations, decimal, percent, fraction. I personally don't really care which one you use unless I specifically tell you which one that I want. Your math space might tell you which one you want. It's always a gamble. Let's say, let's throw in another event here. Let's say B is going to be rolling a number between 2 and 5. Well, event B then, this is between 2 and 5. It does not specifically say or equal to 2 and 5, so those would only be the numbers 3 and 4, which means the probability of event B happening, well, that's 2 numbers there out of 6 possible options, so we got 1/3, which is also like 0.33, which could also be like 33.33 going on percent, so on and so forth. Okay, not too bad so far. We could also look for things like, well, what is the probability of A and B? Okay, well, that might be helpful to know. Well, what is A and B? A intersect B, 2, 3, 4, 6. Pranked, that's the union. Gotcha. Were you paying attention? Just said it weird. So anyway, okay. So the intersection is the only thing they have in common, which is this number 4 here, which means the probability is going to be 1/6. And I could make that a decimal. I could make it a percent. Or maybe I want the probability. Oh, I'm putting probability in green. I'm going to be consistent. Let's say I want the probability of A or B, or the union. This time, can keep this straight, I promise. Well, the union is bringing them all together, so now that's 2, 3, 4, 6. So I got 4 out of 6, which is 2/3. Great. So that only leaves the last one, which is the probability of A prime or A complement. Well, all of the numbers not in A would be 1, 3, 5, so that's still going to be 3 out of 6, which is 1/2. Another way that we can think about it is that the probability of an event plus the probability of its complement, so the probability of something happening versus the probability of it not happening. Well, either way, it's going to happen or it's not. There's no gray area. It happens or it doesn't, which means the probability of something and its complement always equals 1. We call those complementary events. So if I wanted to find the probability of the complement of B or B prime, well, I see here that the probability of B is 1/3. So I could just do 1 minus 1/3 and do it that way, so then I don't have to list out all the numbers. You could list out the numbers and that still works just fine, but that's just a way to look at it. And honestly, that's as complicated as we're going to get with sets, and I think you're going to be okay.